Well, hello everyone, and welcome once again to another Coding Bootcamp 2023 session. This session is called How Secure is Your App? The easy way to find security holes and hidden backdoors. And my name is Ian Barker, and I am the Embarcadero developer advocate. You can reach me on email at ian.barker@embarcadero.com. You can also go and follow me on Twitter or X, depending on what we're going to call it nowadays, because it seems to be changing. Look for my handlers at punctuation and follow me there. And you can also go to my website, which is about.me/Ian Barker, and you'll see my links there. Writing software is only the beginning, really. You learn how to code, and you get good at the techniques, and you start to make things look really cool. You know exactly what you're doing. You're the master of your craft, and it takes a while, but eventually you will get there. You've followed all the best advice. You've been to all the sessions. You've seen how to do styles and add, a look and feel to your app that makes it look really pretty awesome. You've taken some advice on, I don't like that screen. The way this works doesn't work very well. Clicking the buttons should work differently. And, all the best practices that iOS has, for example, or Android has, or Windows or Linux or Mac OS, whatever it is, you've followed that advice and made sure that you're doing it. You are doing the right thing. And once you start shipping it to the customers, the best thing ever happens. Users love your app. They download it or they purchase it, have it installed however you deliver it, through the app stores or off your website. And if it's a web app, maybe they just log in and log into the web app, and things are going well. It's a success and everything is going great. High five, everybody. It's great. But then after a short period of time, that success becomes a problem as well, because the support messages begin to roll in. One by one, your customers begin to send in the same story. Your successful app has been exploited and the customer's data has been stolen. And worse than that, maybe even their whole network is now compromised. They've got some kind of ransomware that came in through a little hole in your app that you didn't know about, some kind of buffer underrun. You know the kind of thing. You see it all the time, SQL injection. There's multiple ways that your app can be compromised. Maybe it's even used a library that's been compromised. This happens with things like Electron apps and web apps and stuff like that. Someone somewhere decides to subvert an old piece of JavaScript or some kind of HTML library that everybody relies on, and all of a sudden there's a whole bunch of vulnerabilities. It's not your fault. You didn't go out, you didn't set out to do anything wrong. All you did was write an app, and you did what you could to make sure that app was working as well it could. And of course, the more success you get, the more chances you are going to have that people will target you and they're going to hack you. And if they do hack your app, or if they do exploit your app, you could be looking at some serious trouble. Because if your app is the vector by which data's been stolen, or you're storing the data in something like Firebase or some other cloud-based system like Amazon S3 or something like that, and you've accidentally exposed the customer's data, or you've had some weak password that you were putting in the testing and you forgot about it. You were going to take it out, but you forgot to do that, and someone discovered what that backdoor password was whilst you were testing and forgot about it. And the data's exposed. Nobody's going to have any sympathy for you. I know this sounds horrible, but that is actually a fact. And you might say, you might be sitting back there and saying, oh, you know what? That would never happen to me. Wrong. That's absolutely wrong. According to the 2021 Sales Data Threat Report, almost half, and that's around about 45% of American companies, suffered a data breach in the previous year, so 2020. Now, an important thing about that statistic is, don't forget that was during the heights of COVID. when actually during 2020 and 2021 people were not going into the office, and actually many businesses in many parts of the world, from China to the US to the UK to most European countries, shut down. Very few people were even going into the office, and yet almost half of the companies that were operating suffered a data breach. And that was at a quiet period. Now the real number, actually, since 2021, because that's slightly out of date, is probably higher anyway, because some of those breaches were undetected and they were exploited, and the person's data was sold, credit card numbers, or social security numbers, tax information, personal data like their home addresses, even something embarrassing like marital problems. I heard of a psychiatry place where they were giving out therapy sessions and all the rest of it, and they got breached. And of course, very confidential records that you would never want to be revealed if you were going there were released, where it was all about the kind of psychological problems he's had, which not only could be damaging in the short term, in the long term, it could even do things like affect their job prospects, because if a person's got issues to do with anxiety or something like that, it could actually affect their future prospects of employment if they're seen to have some kind of disability that would affect their health. It's not fair, but that doesn't mean to say that people don't actually do that and take that kind of information into account. So some people keep that quiet, and so the actual breaches could be higher. Nobody reports the breaches if they think they can get away with it, and it may also be that they're just completely ignorant. They don't know it's happened. And also, according to that Thales data threat report, there was also an increase in the scale, frequency and sophistication of the attacks too. So not only were they happening to 50% of people, but as they carried on through time, they actually got worse, and the amount of data that was breached and the way that it was breached, the sophistication of those breaches increased as well. What does it cost? Well, potentially everything, because it's another thing people say, oh, GDPR, they never ever enforce that law. They don't go around, they don't fine people. GDPR's fine, you don't have to worry about it. It's just one of those laws, that isn't going to be enforced because they don't have the manpower, they don't have the personnel to pursue that. Not true. In Europe alone, and in Europe I'm talking about Germany, France, countries like that in mainland Europe, the supervisory authorities of the EU issued total fines of 1.1 billion euros. So that's about 1.2 billion US dollars, or about 0.9 billion UK pounds, and that was since January 28th of 2021. For the course of that period of time from 2021 to 2023, the end of 2022 actually was the period. So 1.2 billion dollars and 1.1 billion euros. That's a lot of money. So they do fine people. The average penalty in 2019, and again, don't forget this was some time ago, that was 630,000 euros per penalty. So some poor company somewhere was fined 630,000 euros. Now, I don't know about you, but that's an awful lot of money to be finding. And the same is true by 2020, that the average fine had risen. It got worse to more than 1 million euros. And the reason was that enforcement got better, and the penalties to try and deter people, because it was happening more frequently, and the more frequently the breach happens, the more the authorities wish to deter it by increasing the fines. They went up, and so it began to be around about 1 million euros per breach of a penalty. Now there's a sliding scale, and not everybody will get fined that, but a bigger company would easily get €1 million fine. It's a big problem. And also, you can say from this, you should also note that these are 2020, 2021 figures. They've increased since that time, and because they're on an upward trend. And if you don't believe me and say, well, Ian, you're just spreading fear, uncertainty and doubt, which is the favourite thing for people to say, oh, he's just scaremongering, he's just making this up to scare you into going in a particular direction with a product. Here's some sources about those breaches and fines. Because I want you to know that there are facts behind this. I'm not just making this up. I'm not just saying this to scare you. I mean, I am trying to scare you a little bit to wake up to the realities of data protection. And I write, as I say to everybody, get up every day and I write code as a software developer. And a lot of that software development is for human resources software. And we have to take GDPR and HIPAA in the US very, very seriously. So we do care about this particular problem, and actually I'm one of the experts in GDPR in the UK, even though I'm an American, technically. But there's a bunch of facts. And if you think, oh, well, okay, that's quite a lot of information, there are actually some more statistics just to make you even more terrified. Lots of research, 30 plus data breach statistics and facts that show you all the fines and what happened, and a breakdown into what went on in terms of the breach. The data breaches break the record in 2021 from CNET. Employee theft statistics, because it's not just that there's an exploited vulnerability in your app, but it can be to do with exploits internally by your employees. That an employee that has got some nefarious intention actually goes ahead and decides, I'm going to find out about my ex-girlfriend or something like that. And that happens quite a few times in things like parking enforcement, where people try and find out using CCTV an ex-girlfriend's car, where that's parked, and who's visiting that ex-girlfriend or ex-boyfriend. A data breach is not just the names and addresses of people, but it could be anything, like what vehicles are parked down a particular road or something like that. And just to really finish you off and make it absolutely clear that I'm not making this up, and that there are lots and lots of statistics that really do back this data up and say it is a big problem, which is why we're talking about it today. Just in 2021, there were over 18,378 vulnerabilities reported. And that is, the kind of vulnerabilities where if you do this, and this in this particular piece of software, then it's a known vulnerability. And obviously a lot of those get patched. Bigger companies like Microsoft offer things like bug bounties, so to Google. And the idea is they're trying to get you to report the vulnerability that you found, or the exploit or the hack, to Microsoft or Google first, so that they get the opportunity to patch it before you go and release your information to the world and get a pat on the back from your fellow hackers and crackers and exploit merchants. And that's what a bug bounty is for. But that has resulted in a lot of exploits being discovered, but it also means that many people don't patch those vulnerabilities. You'd be surprised how many people will say, I don't install all the security patches, I don't want my machine to reboot. Okay, well, good luck with that, because that's a problem if you're going to go and develop some code on that machine and the antivirus is out of date or something like that. My machines, and I hope yours are the same, are always fully patched, up to date, and got more than one type of antivirus on it, more than one type of exploit protection, and I also have hardware exploit protection on my network router to prevent intrusion through the network that way. And also even internally in the router, it scans packets, and so it's looking for things like a mobile phone app. You go and click on a link, and that link happens to be an exploit, because that can get through your network because of the way that the apps work. So have multiple ways of detecting this because of this kind of statistics that you see on the screen now. Great. So now we're all absolutely terrified and sitting in a corner and crying and going, why did I take up the job of writing software? It's so much easier to go and paint lines down the middle of a road or something like that. Well, you can stop it. It's not easy. It's an arms race between the virus and hackers and the developers and people that are out there to try and con people through things like social engineering, and also through just flat out viruses. So training and understanding what is a real threat. Lots of the antivirus companies got some very good training videos and explanations about how exploits work. Go to the conferences. There are lots and lots of webinars around Kevin Mitnick, who sadly has passed away now, used to have a lot of good information as well. Really, ex-hacker turned a white hat hacker, had a lot of good information that explained to you exactly how threats come about and how he used to exploit human nature. The other thing that you can do, which is a little bit more mechanical rather than actually going and learning about these things and relying on your brain, is using good software development practices. And that means using things like unit tests. And the unit tests will test for things where you pass a string to a numeric variable, for example, and it causes some kind of problem, or pass a buffer that's too big and so the buffer overruns and causes a problem, or you are handling things like null pointers, depending on which programming language you're using, or you've got various other conditions that you can test with unit tests. I know to many people out there, they may say, well, unit tests seems like just overkill, really, because my code is not that complicated. You will find many MVPs out there who will say, actually, unit tests are almost the exact opposite, and they are pretty essential for checking the validity of your code, and also making sure that when you put a new change into a program, that change doesn't then go and impair the code later. And break something that was already working. So it's not just about checking the new code functions, but it checks that the old code still functions as it should do. So it's another way of introducing the vulnerability. You make a change in the program, and later down in another part of your program, it breaks something that was working perfectly well. I know one particular company I've seen before and done some consulting with, they used to say, oh, we'll just give it to the customers to test. And surprise, surprise, and by the way, I stopped working with those people because we couldn't agree on a sensible policy when it came to things like that. But surprise, surprise, sooner or later they came along where exactly that happened. They made a change and it completely broke the rest of the software, and they had to spin out the change that they made so that they could revert it back to working code. I know it shouldn't happen, but it does. The other good practice is code reviews. What's a code review? Well, some people think that a code review is where you get a manager or some senior developer to review what you've written and tell you whether it's okay or not. And that is kind of what a code review is. But a code review is also the ability for a second pair of eyes to look at what you've done and say, yes, they completely agree with it, or no, they don't. It is open to a little bit of a problem, because obviously if you put two programmers in a room and ask them to discuss a particular topic, I don't know, tabs and spaces being the classic, example, you'll find that they'll have very differing opinions. We had one recently with a bunch of MVPs. We were talking about a thing called the in statement in Delphi. And there was a lot of vehement arguing about, oh, it should work this way because that's how mathematics work. And another camp said, no, it should work this way because it's more readable for human beings. And the same happens with code reviews. You can get into a little bit of a situation where the code is reviewed and the person disagrees with the way you did something. But that's not what a code review should be about, unless the way that you did something in the code is a stupid idea and actually will make something worse or more vulnerable. It should be about performance. It should be about whether the aesthetics fit into the overall code base, and whether you've actually looking at the specification for the work you've been asked to do, that it fulfills the specification, but also that it's secure and they can't spot anything obvious that could be a problem. It's a second pair of eyes. If you've never handed someone a letter and said, hey, I'm going to write this to my boss, or my wife or whatever, I just want you to check over it, make sure I haven't said anything wrong or I haven't missed any spelling mistakes. That's what a code review is. It is as much a second pair of eyes to look at something. Peer or pair programming, as it's called, is also another way to improve code security. The reason being that if you've got pair programming, you bounce ideas off of each other. Sometimes it can be distracting, but what generally happens is that two people are working on the same piece of code or the same area of code at the same time, and they bounce ideas off of each other. The idea is that two heads are better than one, and that two programmers looking at a particular problem will hopefully come up with the most optimal solution. Doesn't always work like that. Sometimes it can slow people down. It just depends on your personal feelings. Some people swear by peer programming and pair programming, and other people say they absolutely hate it because they're loners. I'm a loner. I often work for myself and on single code basis without teams, but I have worked in big teams as well. Say 35 developers all working on a project, and we've done peer review and code reviews and peer programming, and it works out okay. It's a personal preference as much as a good reason for doing it from the point of view of good development practices and making something secure. The other thing is code signing all of the executables that you produce. Now, if you're producing an iOS app or an Android app, or actually uploading to the Windows App Store, then you'll automatically be code signing your executables, because that's just how it works. Part of the process of submitting to the App Store is that it gets signed by your own personal developer's certificate. But if you're developing outside of that ecosystem of app stores, then you can just hit compile on your compiler, and out comes a program, and you can stick it on a thumb drive or email it to someone if your email allows you, because that's a great way of getting viruses. But you could just pass it around across a network and it will run. It doesn't need to be code signed, although Microsoft are saying that they're going towards complete code sign enforcement in the next 24 months, I think they said recently. But you don't have to code sign. But code signing has two major benefits. First of all, Windows in particular, and Mac OS is another one, will actually look for a code signature, and it's a thing that's embedded in the application, and it is a cryptographic signature. It means that it's encrypted using a key that only you know, that only you have. And what it does is authenticates that executable, that application, was created specifically by you, only you and no one else. And I've done a whole webinar on code signing, and actually it's just about to change. The code signing is going to very much more secure type of code signing, where you need a hardware dongle that you plug into the machine to ensure that your code signature is definitely from you. It's another step of security. It makes it actually much more expensive, 3 times more expensive, and for some people it's pricing them out of the market, but that's how important code signing is. But the advantage is, if your executable gets virused or someone tries to crack it and put an exploit in it, then the code signature will break, because the code signing certificate actually makes sure that your application is unaltered from the time at which you issued it and created it. That's a very good thing. It's very important. And another thing, which I really can't believe that in this day and age we're still having to mention to people, is that you should use SSL on any websites. And actually any links that you have in your programs where someone clicks on, say, help and go to our website, should be SSL. Okay, so it should have HTTPS at the start of the URL. And there's absolutely no excuse for you not to have a website that's secured by HTTPS or SSL. There is a thing called Let's Encrypt, which is completely free, and it's very easy. Most web hosts now actually support Let's Encrypt, and if you're hosting yourself, it's very, very easy to do. If you're using something like Nginx or Apache, then they support these certificates through Let's Encrypt, which are completely free. Just Google it. There's lots of solutions on there. Ask me questions in the question and answer if you're watching this live, and I'll tell you how to get those free certificates. But you should not be having any links in your program, any links in your help or anything like that are not using HTTPS and SSL. The reason is it's extremely easy to exploit. It's very difficult to exploit SSL. It's not impossible, but it's a lot harder. But also, if you're communicating through the web, down to a customer's browser and you've got a web app, then if you're not using SSL, really, I think you should stop writing code because it's a problem. And if you're using something, let's say you've got an older version of IntraWeb that doesn't support SSL, you can use a thing called a reverse proxy, and we do have a session at some point this week that talks about web apps and reverse proxies. What a reverse proxy does is if your app can only talk HTTP, the reverse proxy will read that HTTP, output it out onto the web as SSL, so HTTPS. It will receive traffic in from the web browser traffic or whatever is going on as HTTPS and convert it back into HTTP to your app. So there's absolutely zero excuse for not using SSL. Stop it, use SSL or else. Systematic multivector antivirus and malware. What do I mean by that? Put antivirus absolutely everywhere on every single machine that you use. And if you're a corporate environment and you're a senior enough person to have some sway in it, make it so that your employees can't turn off the antivirus. Because I know one person, for example, who wanted to use a thing called the Tor browser, the onion router browser, and the antivirus was complaining and saying that the Tor browser they downloaded was virused, and they say it's not that, it's just your stupid antivirus, and tried to turn it off. Luckily, we don't let them do that. We'd actually lock down the passwords and their ability to make that change, because when we scanned it, it was actually virused. It did have a virus. The antivirus was telling the truth. And now, if you've got multiple types of antivirus on your network, it means that if one misses the virus, then hopefully another one will spot that virus. Same with anti-malware. Anti-malware is slightly different to a virus, because some malware is not considered a virus, but it's unwanted, shall we say. There's behavior in there that you prefer not to have, even though it's not, strictly speaking, going to cause damage to your machine. So yeah, have multiple ways of doing it. My network is full of different antiviruses, ones that I trust. And if you ask me again in the live Q&A, I'll tell you which ones I use. I don't want to do it on this webinar. This is going to get repeated for the next couple of years, and let someone else be the vendor about that one. Another thing we can do, how can we stop exploits? Well, we can use a thing called automatic static code analysis. Now, there's two types of code analysis. Okay, one type of code analysis is where it's analyzing your code to see where you've got some bottlenecks, for example, for speed, or where you've done something that is a questionable technique and you could have done it in a more optimal way, or you could have been more efficient. That's one type of static code analysis. Another type of static code analysis is to find vulnerabilities in your code. And what do we mean by vulnerabilities? Well, there's actually quite a whole raft of those types of vulnerabilities, but it could be that you're using a library that's got a known backdoor password or something horrible like that, or there's a vulnerability that's been exploited by a hacker. I once, as part of what I do, I manage about 90 websites, I think, something like that, 90 servers out on the internet with various bits and bobs on it. And one time I was watching a hacker use an exploit tool trying to break a server. They didn't succeed, but they had a tool that was able to send 1 million requests, 1 million different exploits to one of these servers per second. And this is not something you can stop manually. So those guys out there have got some tools that are extremely efficient at cracking your software. It will send a whole bunch of these exploits down and try every combination they can to try and get in. The particular site that happened with was a e-commerce site, and the person was using some very sophisticated techniques to try and hide their IP address. And there are services out there, that will prevent that happening. And luckily we were using it, but otherwise we'd be in big trouble. But it sat there, and I just couldn't believe it. 1 million requests per second, and it was so many that it actually tried to fill our logs up. And luckily, we had a thing called log rolling enabled, which meant that the logs would drop off and not fill our disk space up. But that was another exploit he was trying, was to basically fill our logs up with bad requests and stuff like that. So, and we never caught him, but we did actually prevent him from ever coming back. We managed to mitigate that problem, and we were using Cloudflare, which a few of you have probably heard of, which helped with that immensely. But your app could be subject to the same things, because a static app like a normal .exe or something like that has got nothing to protect it like Cloudflare. It could sit there and someone will run a bunch of code against your .exe and try and look for every exploit they know in your code. And they can find out what version of a compiler you use. They'll find out what version of components that you use. They'll find out, as your program runs, what API calls you're running in Windows, and they can try and find an exploit. And once they find that exploit, they know how to crack your app. They can do the same thing on iPhones and Androids and things like that. It's theoretically supposed to be impossible, but they can actually have a jailbroken iOS device, an Android, iPhone. Jailbroken means that it's broken out of that little Apple ecosystem that protects your app, and they can then run whatever code they like on their iPhone. And they can then look at your app, see how your app communicates, where your app is storing data, and again, with the right tool, they can throw everything they've got, put the kitchen sink at it, and find out where your app has got a vulnerability. What the automatic static code analysis does is exactly the same thing, except for the good guys. So the bad guys have got these tools that are sending all these vulnerabilities down and trying to break your app, and find out, oh, they're using Joomla version 2.4, and there's this particular exploit where if you type in 3 backspaces into the password box, then such and such happens. Well, the automatic static code analysis does exactly the same thing, but it tells you about it rather than tells a hacker and tries to exploit you. So that's the point of static code analysis. And so another bit along the lines of so how do we stop it? Well, we go and use a product called DirsScanner.com, and actually the product's called DirSecure, but the website is DirsScanner.com. They are a new Embarcadero official technology partner at the time of recording this. In fact, they're so new they haven't actually got the logos on the site, and they're signing up, but we've agreed everything, and they're a tech partner. Got a very interesting product called DirSecure, or DirScanner is the name of the website, and I personally I keep forgetting that the product's called DirSecure, but if you go to DirScanner.com you'll find it. And as you can see with the little thing there, it reduces time to market for your apps regardless of the vulnerabilities. So what it's doing is this static code analysis that I was just talking about. How does it work? Well, you log on to DirScanner on their website. It's a web interface. You load your project source code directly in, or link to the repository where your source code is, and this does work with Delphi code. It also works with all sorts of other things like JavaScript and C++ and Python and all sorts of frameworks, Joomla, and you name it. It's got a scanning technology for it. It's quite overwhelming, the amount of different versions that they do. And they charge per scan, but that scan is very comprehensive. And what happens is, and you wouldn't do this straight away, but you hit the scan button, and it will then go and look at your project and analyze every single piece of your source code and look for the exploits and all the things where you could be making big mistakes. Once it's done that, you can go and sit in a corner, hug yourself, and rock yourself back to sleep as you sob very quietly. Because I guarantee, based on my experience of what I've seen this tool do, it will find vulnerabilities in your code. I don't know. Maybe you're lucky. Maybe it won't. But I think any project of sufficient complexity, it will find problems with your code. It's quite distressing, really. How does it work? Well, they've got a little graphic here, and some of it's got some jargon on that I don't particularly understand, and I don't think it's necessary for me to explain. It's kind of industry jargon, but what it does is it goes and looks at the repository or your source code, and with Delphi I think you just can upload a zip file with the source code in and it does it. But it can either do the source code or it can do the binary code, depending on if it's one of those versions that's supported, and it will go and analyze it. It will look through and produces a type of representation. I'm not quite sure what it means by that, but I think it's kind of like an in-memory model of how your app works. And then it will also look at various other types of things, like get rid of the obfuscation if you've obfuscated your code, and decompile if it's a binary executable. Pretty scary stuff. And then once it's done that, it will go through and use its logic engine to infer some of the things that it doesn't know about. So it uses a little bit of kind of, it's not AI as such, but it is a little bit of intelligence where it finds vulnerabilities that it doesn't necessarily know vulnerabilities, but believes there probably are. The list of vulnerabilities and undocumented features in your app, which is another thing it does. It could be that there's not really an exploit in your app that's exploited by a hacker, but it could be that some crafty developer, especially if you've got a large development team, has decided to put an undocumented feature in there. I remember one company I worked for in the 1980s, so it was a very long time ago, so I think I'm safe mentioning this. They used to have a Jeep. They used to drive a little Jeep, Suzuki Jeep, I think it was. And there was a Rhino logo on the back tyre. And I remember finding out as a senior developer there that someone had put some hidden feature in the program where if you pressed a key combination on a certain day, it would show two ASCII art of two rhinos mating. Now, in the development office, everybody thought that was absolutely hilarious. Oh, look at this, it's very cool. It's a harmless thing. It didn't show anything particularly explicit, but it's two rhinos mating, because it was a Suzuki Jeep and the logo at the time was a rhino. But of course, that's all very well, except the software that we were writing was going out to very big corporates, and I'm talking, multi-million pound, as it was, because in the UK, multi-million pound businesses. And if that vulnerability had been discovered, that undocumented feature, my apologies, if that undocumented feature had been discovered and someone had pressed that key combination by accident or deliberately, and up comes some mating rhinos, we could have lost a lot of money. It could have been tens of thousands, hundreds of thousands of pounds. And we probably wouldn't have got sued, but if we offended enough people, or we caused the customer to lose faith in what we're doing and thinking we're all just a bunch of jokers and having a laugh, they might have refused to pay for the work that we'd done or something like that. And also, of course, that undocumented feature, which was very clever and funny when, as I was, a young man at the time, probably 20s, if that, we all thought it was hilarious, but also I was kind of sensible enough to realise that meant that our company had probably paid that developer to write that code, and that was a bit of a problem. So undocumented features, not always a bad thing, but they could be if that undocumented feature is a backdoor, so that a banking app, a person could log on to any person's phone and get into the banking app without knowing the user's password. That would be an undocumented feature that is a problem. And of course, if a hacker knows that backdoor is there for technical support purposes or training or testing or whatever, the hacker can exploit that, and they can use it for bad purposes. It may be that your programmers don't use it for a bad reason, but of course a hacker could. And so on and so forth. So there you go. It's all sorts of different bits and bobs. Now, what we'll do is we'll go and have a quick look at how this works. It'll be a fairly quick demonstration because the scanning itself takes quite a long time, and also it costs quite a lot of money to do the scan, so I'm not going to keep triggering those every so often. Let's have a look now and look at the demo. Okay, so when we first log in, what we do is we go to this web interface, and this is a web-based product. So most of what you see there is, web-based and fairly straightforward to understand. You'll have a number of projects in there. I've actually only got one. There's a sliding scale for the pricing on there. If you're a big corporate, then the amount that it costs for this project, what you would do is write a code and get everything ready to the point where you think you're going to actually release it, and then you're doing the pre-acceptance phase, shall we say, before you're actually going to release this out into the world, and where you're actually going to try and see if there is something that may or may not be wrong with your system. So you'll run your scan. Now if I go into this and choose my particular project, this is test data supplied by Scanner, so none of it is real, it's all fake data. However, the source code in there is real source code, and those vulnerabilities are real. As you can see, it will give me a tally, quite a horrifying tally, of how many vulnerabilities there are in this project. It's quite a large project, although not really for most Delphi programs. That's 836,000 lines. I personally work on projects that are over 1.5 million or more. So, 836,000 is nothing to be sneezed at, but it's not that big in the general scheme of things. Let's go and have a look at some detailed results. Well, the detailed results are really quite distressing. For example, if I go and choose critical in here, some of the vulnerabilities, there's 6 of them where there's an empty encryption key. Okay, so what is that? If I click on that, it expands down. If I click on here is the source code. And as you can see, if you're a Delphi programmer, this is the real thing. This is actually proper source code. And so it's saying here that this particular feature here is empty. So what they've done is they've pre-initialized it, as you should do, assign variables values to make sure that they've all got deterministic values to start off with, and you're not accidentally using corrupt data, uninitialized data. That's the word I'm looking for, uninitialized data. But it also then explains why that's a bad thing. Okay, so it tells you what is wrong, and then luckily explains what on earth that thing is, because you do need to know, what on earth is this problem? Why is it a problem? And it gives you examples of how that works, recommendations on how to fix it, links to where this kind of vulnerability has been reported before, and the top kind of things that there are, classifications, program traces, and all the rest of it. There's lots and lots and lots of those, like this one, empty password. Again, this is all example stuff, but it's connecting to a ini file here, and it's saying, okay, if you're a Delphi programmer, you know that I will try and read this password to access this Banco which I'm guessing is some kind of test bank example, and it's actually beginning to with the password set to nothing, to an empty thing. It goes and uses that connection string. So if that works, or it stores that back later and stores that password back, you've now got a banking database that has got a username that's blank and a password that's blank. Now, reality is that probably wouldn't happen to do much, because most DBMSs wouldn't like that kind of configuration anyway. But let's just imagine this line was on its own somewhere else, and you had that kind of piece of code. You wouldn't necessarily spot it. I'm sure I've written that code once upon a time. I've written hundreds and hundreds of thousands of lines of code, if not, nearly a million lines of code over the course of 38 years. I bet you at some point I've written this line of code, because I'm not that great a programmer. I'm going to get it wrong, but it's quite terrifying. So all sorts of things like that. Medium vulnerabilities are quite interesting. Like this one, you remember I mentioned why I used not using SSL. This, I think, in many ways is actually very useful, because you can then go and spot all the times that you've actually called a URL without HTTPS in. Okay, you could use grep, you could use some Linux command line magic or something like that. It just depends on how good you are. But at the end of the day, it's going to spot these kind of exploits, potential exploits. I really like it. I'm not going to go into a great detail of this because this is actually quite a huge app, and their website is very comprehensive, and they've got some videos as well. Kate, who's my opposite number at Scanner, she does developer relations there, went through this and gave us some in-house demos and things like that. But you get the general gist of what's happening. It's saying you shouldn't use these functions, and then you think, well, why not? I've seen code on Stack Overflow that says that all the time. Well, yes, it may well say that on Stack Overflow, because the answer that you're picking up on Stack Overflow was written in 2009 when it was perfectly safe. But 2009, at the time that we're recording, this is 14 years ago. 14 years. So in 2009, the iPhone was still a very basic device. For example, the internet did not have gigabyte speeds, and yet you're still using example code that you're pasting in from Stack Overflow, which could be out of date compared to the modern world of software development. So it's slightly an eye opener, shall we say, if you go through it. But anyway, that's it. Just scan it. Very interesting stuff, and I quite like it. Okay, well, I hope I've terrified you enough to take things seriously. I don't mean to be horrible. I don't want to scare you, but at the same time, I do want you to understand that software development isn't just about writing the code. This whole bootcamp is about the entire process of software development, and part of that is also things like this kind of static code analysis, taking security seriously, worrying about things like GDPR and whether you should or shouldn't breach them. As a developer, if you're a senior developer, and perhaps you might be the only developer in a company, because that happens a lot, quite often the buck will stop with you when it comes to security and comes to preventing data breaches. If it does stop with you, then you do not want to be the scapegoat for problems. You want to make sure that you've adopted the best practices you can, and I've tried to illustrate a few of them here. Tools like Scanner or Secure are very useful in helping with that. There are others out there that do static code analysis. I'm not focusing on them right now. I just want to cover this particular one. But do yourself a favour and adopt some of the best practices and use tools like this to try and find out exactly where there might be a problem. Let them do the hard work. Let them do all the scanning for you, and save yourself a headache so you don't have to go through lines and lines of code manually and go, I wonder if this is a problem. You don't need to. They've got a tool for that. Anyway, my name's Ian Barker, and I'm the Embarcadero Developer Advocate. You can email me on ian.barker@embarcadero.com, or follow me on Twitter /X at @punctuation, or go to my website about.me/Ian Barker and find me there. Thanks for watching.